Welcome to the Technology Innovation Series of SH Vision. As you can see, today I am doing the presentations from the Fab Lab at Jyoti Engineering College. At present, in the state of Kerala, there is a series of Fab Lab constituted. It is under the auspices of MIT in the United States, as well as in collaboration with Abdul Kalam Technological University or KTU. It is a kind of abode of innovations. Here, the students or those who are using the lab, they will be able to create their prototypes. They can translate their ideas into actual working models, and which will eventually can be turned into a product. So this will enhance entrepreneurship. So that is the idea. But today I will discuss about Fab Lab in another episode. But let's start with what we have discussed in the last session. We were discussing about the age of machines in the last session. The new job seekers of this century and decade, they need to work with machines, some powerful algorithms, and these powerful algorithms are enabled by some powerful machines, and those machines are called supercomputers. So what is a supercomputer? As the name signifies, we can say that it is something big, huge, a very big, huge computer which can process things in a much, much faster way. Only very recently, I think the last week of June, a new supercomputer was unveiled in United States, and it is supposed to be the fastest supercomputer, and it is called, or it is named as Summit. It is installed in Oak Ridge National University in Tennessee. They already houses another supercomputer. It is called Titan. But they think that they will decommission this particular supercomputer, the Titan, maybe in a couple of years' time, maybe in 1 or 2 years. So that's why they have brought in another one. And to our surprise, with the coming of Summit, US will reclaim the fastest supercomputing title. When I say that US will reclaim, it also indicates that they lost that title. So they lost that title in the past few years to China. So we will talk about that story in the coming sessions as well. Just let's have a look into this new supercomputer, that is the fastest supercomputer, which is not been listed till now, but they predict that it will have a capacity of 200 petaflops. The speed of the supercomputer, a supercomputer is defined by its speed, and the speed of the supercomputer will be 200 petaflops. Now these numbers are very interesting. First of all, to a novice, to a newcomer, these terminologies may be daunting. So what is peta? We know that peta means 10 raised to 15, which means we have to put 15 zeros after 1. So that is the number. And then what is flops? Flops means floating point operations per second. So when we say that Summit has got a speed of 200 petaflops. It means that it can do 200 into 10 raised to 15 floating point operations per second. A floating point operations, by the way, we can understand something like this. If I say 1 plus 1 is equal to 2, that is not a floating point operation. But if I say 1.0 plus 1.0 is equal to 2.0, then that becomes a floating point operation. That means when the decimals come into play, the computing power that needs to calculate the decimals is much higher. So that's why there is a difference between the first one and the second one. The calculation, even though it appears to be the same, computationally it is different. So these many operations like adding, subtraction, etc. with decimals, and these operations we can do in these many big numbers in per second. So that is the game changer here. We got our laptops, we got our desktops, maybe our workstations, maybe even our servers. They can do bit, but they cannot do the same work as what a supercomputer would do. I will give a simple example. One of the lecturers, one of my colleagues, she was doing a PhD work. She was doing that in bioinformatics, a lot of DNA decoding, etc., and pattern matching. Some of the programs she used to run in a desktop machine, and it would take maybe 12 to 13 hours to complete one single program. And I developed a small HPC or high performance computing cluster in Rajgiri and at Shunya Labs. And when she ported her codes into this Shunya Labs, she could do that within 10 minutes. So that is a kind of difference it makes. But Shunya Labs compared to Summit is nothing, it's tiny. Then how do these supercomputers affect us? It's going to affect each and every one of us, the common people. Just think about the case of Watson. Watson is the supercomputer developed by IBM. It is a legacy supercomputer. It has got a lot of history. It has defeated chess champions, and it has defeated human intelligence many times. Finally, IBM decided to open up Watson to the public. Especially, they specialized in legal matters. You know that most of the legal work is referencing, and all of the legal data is available. For example, different verdicts and laws, etc. These are available in a document form. So they uploaded all of this and then ran some artificial intelligence algorithms on the top of it and made the service available to the legal firms. And what happened? It says that in the United States, now the need for legal people or legal attorneys, advocates are dwindling, and dwindling like anything. They are losing their jobs. It is just because of Watson. What Uber has done to taxi drivers, Watson is doing to the lawyers, and lawyers are supposed to be white collar jobs. We never thought that white collar jobs will be affected, but they are now being affected, and it is only because of this particular machine. There is Watson. It's again a supercomputer, and that's the reason why we need to understand this beast in a better way and make use of this particular technology for our development. as a nation, as a society, as a human race. So we will talk about that in the next session.